Rectangular hyperbola. So what is a rectangular hyperbola? It is a special case of a hyperbola where the length of transverse axis is equal to length of the conjugate axis. That is, if I take the parabola, this hyperbola, this in the standard form as x and y-axis, then length of transverse axis, which is between A and A dash, that is between those two sides, which is 2A, and must be equal to length of the conjugate axis, which is also to be, in this case, called rectangular hyperbola. We have 2A equals 2B. That is, length of transverse axis is equal to length of conjugate axis. Length of transverse axis is equal to length of conjugate axis. That implies A is equal to B. So for rectangular hyperbola, the condition is equal to B, or length of transverse axis is equal to length of conjugate axis. Rectangular hyperbola is a special case of a hyperbola where A is equal to B. Now let's derive the equation of rectangular hyperbola. Now we know that rectangular hyperbola is a special case of an hyperbola where A is equal to B. So here we're going to take the equation of rectangular hyperbola as a special case of an equation. So as we have here, the standard form of equation of hyperbola, as we know, is in this form. So for rectangular hyperbola, I have the condition A is equal to B. That implies x squared by A squared minus y squared by A squared equal to 1, where B is replaced with A out here. So in this case of B gets reduced to A. Then that implies I get x squared minus y squared equal to A squared. Is how I identify the equation of rectangular hyperbola is x squared minus y squared equal to A squared, where 2A is length of transverse axis or the conjugate axis, where I can say that A is half the length of transverse or conjugate axis, is how I derive for A. So therefore, for rectangular hyperbola, only have A but not B, simply because A is equal to B. Substituted reduces to x squared minus y squared equal to A squared. Now let's find the eccentricity with hyperbola. The condition is A equal to B. So with this condition of A equal to B, my eccentricity is related with this, such that E squared is A squared plus B squared by A squared. So we had the eccentricity derived with this as the formula. Now A equal to B implies E squared reduces to A squared plus A squared by A squared using A equal to B. Now again, this on further simplification gives E squared equals 2A squared by A squared. And this gets cancelled because A is not equal to 0. Both A and B are not equal to 0. I have this which can be cancelled. Therefore, I get E squared equal to 2. Now this leads to E equal to plus or minus root 2, which I take on the right. But I don't take the negative side because since E is greater than 1, Therefore, I have only one value for E, that is root 2. Therefore, I conclude that for rectangular hyperbola, the eccentricity is root of 2. So, the condition for rectangular hyperbola condition is E equals root 2. This is the condition for rectangular hyperbola. When eccentricity is root 2, or when SP by PM is root 2, then this leads to the locus, which is a rectangular hyperbola. The locus of points derive a rectangular hyperbola if the eccentricity is root 2. That is, SP by PM is equal to root 2 in the ratio. Now next is auxiliary circle. Now what is auxiliary circle for an hyperbola? As we see that an hyperbola has both transverse and conjugate axis, we have this x-axis, y-axis, and this is origin. Now using this, we are going to describe the auxiliary circle taking the length of transverse axis as the diameter. So if I take the diameter A and A dash and describe a circle along that, then we call this circle as auxiliary circle. So this is called auxiliary circle, and its center is origin and its radius is simply A. As can be seen, the distance from center to A is small a. So radius is A and the center is origin, is how we identify the auxiliary circle. Now we know that if the center is origin, for an auxiliary circle, the center is origin and radius is A. Therefore, equation of auxiliary circle would be in the form. Therefore, equation of auxiliary circle is given by the equation x squared plus y squared equal to a square. An auxiliary circle is described for a transverse axis as the diameter, and its center is origin and radius is a, and equation of this auxiliary circle is x squared plus y squared equal to a square. Now let's discuss about the parametric equations of hyperbola. Now, as we have discussed the parametric equations of a circle, a parabola, an ellipse, etc., similarly, we have the respective parametric equations for an hyperbola. To discuss in the session about parametric equations of hyperbola. So here I take the standard form of hyperbola, which is with x-axis, y-axis, and then I get out here like this. Now for this, I have the equation of this hyperbola is given by x squared by a squared minus y squared by b squared equal to 1 with a greater than b. Now for this, if I take any point P out here, then let me join the center of hyperbola with the intersection this point P. And let me say this point P makes an angle theta in anti-clockwise direction. Then this point P is said to have the the x and y coordinates connected with angle theta and with A and B, because if I have x equals A secant theta and y equals B tan theta, then these two parametric equations clearly satisfy the hyperbolic equation, as when substituted with x as A secant theta whole square by A square minus B tan theta whole square by B square, which is the left hand side of substitution, gives us this on A square by A square cancelled, secant square theta minus tan square theta, which is equal to 1. That is right hand side. That is, these two equations satisfy the hyperbola x square by A square minus y square by v square equal to 1. Therefore, every coordinate P is given by A secant theta and B tan theta. And this is called the parametric point. And the parametric equations of the hyperbola 1 are given by x equals A secant theta, y equals B, this with 0 less than or equal theta less than or equal to 2 pi, because theta ranges from 0 to 2 pi in one full revolution or rotation of the angle. So theta ranges from this, and the parametric equations of the parabola in standard form are x equals A secant theta and y equals B tan theta. Now let's discuss about the parametric point of the hyperbola. Now, as we know that the point on the hyperbola can be taken as coordinates with A secant theta and B tan theta, where theta is the angle made by the center of hyperbola with the point along x-axis in the anti-clockwise direction. So this theta connected with the coordinates of P or any point on the hyperbola are very much connected with the parametric point. A point which is taken generally in the form P of theta, which is A secant theta and B tan theta, is called the parametric point for the given hyperbola. So any point on the hyperbola can be expressed as A secant theta, B tan theta for that respective angle theta lying between 0 and 2 pi, and that point denoted by P of theta is called the parametric point, and theta is called the parameter because this measures the point. As the angle changes, the point changes. So this is the criteria for changing of the point, and hence it is the parameter or the decision factor for the parametric point. Theta is the parameter, P of theta is the parametric point of the hyperbola x squared by A squared minus y squared by B squared equal to 1 with A greater than B. Conjugate hyperbola. So what is a conjugate hyperbola? An hyperbola with transverse and conjugate axis interchanged with the original hyperbola is how we define the conjugate hyperbola. So let's see how we define the conjugate hyperbola in today's session. Let me take the equation of hyperbola in standard form with x-axis and y-axis out here. Suppose I have the hyperbola S is x squared by A squared minus y squared by B squared minus 1 equal to 0 with A greater than B, then I would like to define the conjugate hyperbola for this. In that case, my transverse axis, which is 2A, will act as the conjugate axis for the hyperbola. We are interchanging the conjugate and transverse axis, so this length gets here and this is a dash, and b dash. So if I draw a hyperbola passing through this and passing through this hyperbola is called the conjugate hyperbola of this. So this hyperbola is called the conjugate hyperbola because its transverse axis is the conjugate axis of the hyperbola, and its conjugate axis is the transverse axis of the original hyperbola. So with those transverse and conjugate axis interchanged for this hyperbola is called the conjugate of the given hyperbola this. So if transverse axis is interchanged with conjugate axis of either of the hyperbolas, we get a conjugate hyperbola. Now, as we know that the equation of the original hyperbola is x squared by a squared minus y squared by b squared minus 1 equal to 0 with a greater than b, then equation of conjugate hyperbola is given by s dash equals x squared by a squared minus y squared by b squared plus 1 equal to 0. Is how I identify the equation of conjugate hyperbola, which is x squared by a squared minus y squared by b squared plus 1 equal to 0 with a greater than b. So these two hyperbolas differ by minus 1, which is for original, and plus 1 for the conjugate. So they differ by the sign of unit 1, minus 1 to plus 1 and plus 1 to minus 1. Conjugate hyperbola of the given hyperbola. Now let's see some properties connected with conjugate hyperbola, that is, what is the focus or the foci, directrices, and various other properties of conjugate hyperbola. So as we take the parabola in standard form connected with conjugate, is how we get for the conjugate hyperbola has the foci S and S dash and B dash, and of course A and A dash is how we see each of the properties of conjugate hyperbola. Now the foci of conjugate hyperbola are 0b, with equation of conjugate hyperbola is x squared by a squared minus y squared by b squared equals minus 1. So here S is this, and S dash is 0 minus BE, and coordinates of B is 0b and 0 minus b. My A, which is a comma 0, and my A dash, which is minus a0, and C, which is the center of hyperbola or conjugate hyperbola, is given by this, and length of transverse axis, that is, if I take the transverse axis of this, it is BB dash, because as I see the hyperbola is constructed along this, so BB dash is the length of transverse axis, and BB dash is nothing but 2B, and length of conjugate axis, which is AA dash, is given by 2A, which is nothing but 2A units. So length of transverse axis and length of conjugate axis are given by 2B and 2A respectively. Is how we define each of the properties of foci, the center, coordinates, and all other properties which come in conjugate hyperbola. Even the directrices can be defined by taking a line and then defining the equation with respective properties. Conjugate hyperbola is connected with hyperbola with the equation this and the following properties. The directrices which pass through this are given by the equations y equals b by e and y equals minus b by e, because each of the directrices are b by e units from the x-axis, that is x and y. So the directrix on the top is given by y equals b by e, and the directrix below is given by y equals minus b by e, and the eccentricity which we have for conjugate hyperbola is a square plus b square by b square. That implies E equals root of a square plus b square by b square. Is how we define the eccentricity for conjugate hyperbola. Eccentricity is root of a square plus b square by b square out here. Rectangular hyperbola of the conjugate hyperbola. Now that we have discussed about the rectangular hyperbola, now we're going to discuss on how the rectangular hyperbola looks for the conjugate hyperbola. So as we have discussed about the conjugate hyperbola, to be with interchanging of transverse and conjugate axis, its rectangular hyperbola would be with a equal to b. So I get this equals this. A conjugate hyperbola is a rectangular hyperbola if this and this are same. That is, AA dash is equal to B, B dash. That is, A is equal to B is the condition, or length of transverse axis is equal to length of conjugate axis. Is how we define the rectangular hyperbola for a conjugate hyperbola. Therefore, in case of conjugate hyperbola being a rectangular hyperbola, both the hyperbolas pass through like this. Is how this is the original hyperbola, this is the conjugate hyperbola, which is also a rectangular hyperbola, provided this and this are equal. And we know that the rectangular hyperbola of this is equation of this hyperbola is x squared by a squared minus y squared by b squared equal to -1. Therefore, a equal to b implies I get x squared minus y squared equal to minus a squared. That implies y squared minus x squared equal to a squared is the equation of rectangular hyperbola, which is conjugate of the original hyperbola. So equation of rectangular hyperbola of a conjugate hyperbola is y squared minus x squared equal to a squared, as can be seen here. Now here, let's find the conjugate hyperbola in transformed form with all its properties. That is, if I have a conjugate hyperbola in the transformed form, then let's find the properties like foci, directrix, etc. for this transformed hyperbola in conjugate form. Now, as we know that this is in conjugate form because it's -1 on the right, I have now this hyperbola is the conjugate form, and we know that it has the vertices b and b dash, but this is not x-axis and y-axis, but this is a transformed axis other than x and y-axis. Now here my center is hk, and my coordinates of b, which is 0b, will be h b k plus b and h k minus b, and I have a dash and a, which is a0 is how we get it. Now in this case, the focus, which is S, and the other focus, which is S dash, is given by 0 BE, that is H and K plus BE, and here it is H and K minus BE, is how each of it is transformed. Say for example, I want to find the directrix then this is given by y equals k plus b by e, and this is given by y equals k minus b by e in the transformed form. So each of the properties are derived through the formulae where length of major axis, the length of transverse axis of the conjugate hyperbola is given by 2b, and length of conjugate axis is given by 2a, and the rest of e square or e is root of a square plus b square by b square, are the one which we identify for the transformed hyperbola x square minus x minus h whole square minus y minus k whole square by b square equals -1 in its transformed form.